Hey, so now it's our turn to take up question number 23, which also hold 3 marks. We were also given the choice in this question also, and we are going to deal with the first choice of this question first. And here we have the first part of the first choice of the question. This says state Gauss law for magnetism and explain its significance. So if we have a look onto the answer of this question, so what is Gauss law? Gauss law for magnetism states that net magnetic flux through a closed surface is 0, and this is how we define it mathematically. So the closed integral of the dot product of the magnetic field and the surface is equal to 0, which means the flux that is linked through a closed surface is always going to 0. What is its significance? Its significance is that the monopoles do not exist. So basically this Gauss law of magnetism tells us about the non-existence of monopoles, and you have written this as the answer in your exam, then you are going to score 1 mark for this question, because this part of the question was for 1 mark. Okay, let's have a look on to the second part of the question, which holds 2 marks. This part of the question says write 4 important properties of the magnetic field lines due to a bar magnet. Well, this is a very pretty simple question. You just need to write down the 4 properties. So you will be getting half mark for each property. So you can write the field lines form closed loops. Field lines do not intersect each other. There is no need to write down the reason for that why they do not intersect. You can just write down that they don't intersect. Degree of closeness of the lines represents the relative strength of the field in the regions, and direction of the magnetic field at a point is along the tangent to the field line at that point. So basically you can get the direction from the magnetic field line by drawing the tangent at that point where you need to find out the direction of the magnetic field. So these were the 4 points, and you will be getting half mark for each point, and this is how you will be getting the complete 2 marks for this part of the question and 3 out of 3 for this choice of the question. Now let's have a look on to the second choice of question number 23. This says write 3 points of differences between the para, dia and ferromagnetic materials, giving 1 example for each. Let's have a look on to the solution for this question. So here we need to differentiate paramagnetic, diamagnetic and ferromagnetic materials. So here we need to differentiate them on the basis of 3 parameters. So first parameter that I have taken is on the basis of the attraction and repulsion when they are placed in the external magnetic field. So here you can see, if we place the paramagnetic material in the external magnetic field, these materials gets weakly attracted by the magnet. Okay. On the other hand, if I place the diamagnetic material, they will be weakly repelled by a magnet. On the other hand, ferromagnetic materials gets strongly magnetized when placed in external magnetic field, because they are strongly attracted by the magnetic field. So here in this first parameter, I have mentioned the differences between the para, the dia as well as the ferromagnetic materials on the basis of the attraction and repulsion from an external magnetic field or from a magnet. Okay. Moving on to the next point of discussion, where I have taken up the parameter of susceptibility. So the magnetic susceptibility of paramagnetic material is positive and it's small. Now as it is positive and it's small, so field lines concentration increases inside the material. So when a paramagnetic material will be placed in external magnetic field, what will happen? Because of the positive value of magnetic susceptibility, magnetic field lines will try to pass through the paramagnetic material, and hence the concentration of the magnetic field lines inside the paramagnetic material will increase. On the other hand, the magnetic susceptibility of diamagnetic material is negative and small, and because it's negative, the concentration of field lines inside the material decrease once you will place it in the external magnetic field. Okay, moving on to the ferromagnetic material. The magnetic susceptibility of a ferromagnetic material is positive and very large. Therefore, the concentration of magnetic field lines increases very much inside the material. Okay, so there is going to be increase in the magnetic field lines inside the ferromagnetic material because they have the large value of magnetic susceptibility. Moving on to the next point of parameter, that is going to be the temperature. Now, paramagnetic material or the paramagnetic nature of the material decreases with increase in temperature, and the example is aluminium, calcium and sodium. Moving on to the diamagnetic material, diamagnetism is found in every material at low temperature. They behave as a superconductors. Okay, so this is about the temperature dependence of the diamagnetic material. So at low temperature they behave as a superconductor. Bismuth, copper and silicon are the examples of diamagnetic material. Now ferromagnetism also decreases with temperature. At Curie's temperature they become paramagnetic. Examples of ferromagnetic materials are iron, cobalt and nickel. So here we have taken up the differences between the paramagnetic, diamagnetic and ferromagnetic material on the basis of three parameters. The first one is attraction and repulsion in the external magnetic field. The second one is the magnetic susceptibility and the third one is the temperature. Okay. So out of these three we will be getting 1 mark for each difference. So you will be getting 1 mark for this, 1 mark for this and 1 mark for this difference. And do not forget to mention the name of each material, as in the question you were asked to give one example of each. I have given you the 3 examples for each, so you can write any one of that. So if you have written the answer of this particular question in this manner, you are going to score 3 out of 3 marks for this particular question. I hope this is very clear to you. Now let's move on to the discussion for the next question. Hey, so now let's have a look on to the next question. That's question number 24. This question is also for 3 marks and there were 2 parts of the question, and first part is going to be for 1.5 mark and the second part is also going to have 1.5 mark. So if we read the first part of the question, this says the 3 photodiodes D1, D2 and D3 are made of semiconductors having band gaps 2.5 electron volt, 2 electron volt and 3 electron volt respectively. Which of them will not be able to detect light of a wavelength 600 nanometer? So let's try to answer this part of the question. So we are given the band gaps of diodes, D1 as 2.5 electron volt, D2 as 2 electron volt and D3 as 3 electron volt. First of all, we will calculate the energy that is associated with the photon of the given wavelength. Okay. To calculate that, we need to use this formula, that will be h nu. To calculate nu, we will be using C by lambda. So E will be equal to h C by lambda. When you will substitute the values, you are going to get E as 2.1 electron volt. Now to detect the light, the band gap should be less than E. Okay, so the energy that is associated with the given photon should be greater than the band gap. And if you have a look here, the band gap is less only in the case D2 or in the case of diode D2. So you can write here that only diode D2 will be able to detect the light. Now when you will solve this question in this manner, 1 mark you will get for solving it till here, that is for calculating the energy that is associated with the given photon of wavelength, and half mark you will get when you will explain this part, that the light will be detected only if the band gap is less than the energy that you have calculated. Okay, so this is how you will be scoring 1.5 mark for this part of the question. Let's have a look on to the next part of the question, which says why photodiodes are required to operate in reverse bias. We need to explain this. Let's have a look onto the explanation. So here we know that the photodiodes are operated in reverse biased, and why it is done so? Because the depletion region is large in the case of reverse biasing, and the electric field strength is very high in that region, and the current through the circuit is very small. So we have seen that in the case of diodes, when it is reverse biased, the current in the circuit is very less because the depletion region is very much large. Okay, and also the electric field that gets sets up in the depletion region is very high. Further, all these things facilitate the easy detection of light. Now, why we are using the reverse biasing? You need to mention here this line that all these conditions actually facilitates the easy detection of light. So, because of these reasons, it's easy to detect the light. Now, how it works? You need to mention that also. When the light photons get incident on the depletion region, so you can even draw this diagram, and even if you will not draw this diagram, then also your marks are not going to be deducted. Okay, but you need to mention in the exam that why and how this is going to work. Okay, so light photons gets incident on the depletion region, they generate new pairs of holes and electrons, and due to strong electric field, these new generated holes and electrons gets separate out and constitute the rise in electric current in the circuit, which indicates the detection. So this is how this works. I hope this is quite clear to you. So you are going to get 1 mark for explaining this, and you will get half mark for explaining its working, and this is how you are going to score 1.5 mark for this part of the question and 3 out of 3 marks for this complete question. I hope this discussion is quite helpful. Let's move on to the discussion for the next question.